Hey everybody, in this video I'm going to give you a series of steps that will draw Lewis structures correct every single time. In this example we're going to draw the Lewis structure for NH3. The first thing you do is arrange the atoms. That means pick one atom to be in the middle, we'll call it the central atom, and the others are going to go symmetrically around it. In this case, and in most cases, the central atom is simply the one that's written first, or it's the one that there's only one of, so it can actually be the one atom at the center. The others you're just going to sort of distribute as symmetrically and evenly as possible. It doesn't really matter where you put them, and we can adjust their positioning later if needed. Also, part of step one is counting up the total valence electrons that the molecule has. We're going to keep track of that total as we go. Nitrogen brings in 5 valence electrons. Each hydrogen brings in 1. If I add those together, it's a total of 8 valence electrons, and we have to make sure we use all 8 of those when we bond these atoms together. Step 2 tells me what I should start doing with those 8 valence electrons, and the first thing we're going to do is put in single bonds to connect each atom. Single bond here uses up 2 of my 8. Another single bond uses another 2 of my 8. And a third single bond uses another 2 of my 8. We're going to keep track of these quantities as we go. Of my original 8, I just used up 6 electrons, and there's only 2 left. Step 3 tells me the next thing I should do is give octets to the outside atoms first. Octet, of course, meaning 8 electrons. That's the magic number for each atom to achieve chemical stability. And it also tells me that we're going to do this for the outside atoms first. And yes, the order that you do it matters. Here, my outer atoms are hydrogen. Each hydrogen already has 2 electrons in the bond, so to get it up to 8, I have to give each hydrogen an additional 6. And you're just going to go around and do all of that for the outside atoms first. In this example, however, we've got to pause and actually back up and correct a mistake. Something not written here for step 3 is, I'm going to add this in myself, is that there is one exception to this octet rule for an atom that is so small, in this case it's hydrogen, that it can achieve chemical stability not with 8 total electrons, but only 2. If I look back at these hydrogen atoms, they already have 2 electrons, even with just the single bond that I gave them first. So when hydrogen is your outer atom, you actually don't need to do what I just showed you. So I'm going to go back and erase all those, because these hydrogens are chemically stable as is. You don't really have to give them any extra electrons. To keep track of how many electrons are left, that number is still 2, because I didn't need to really do anything here for step 3. Step 4 tells me to give any extra electrons to the central atom in the form of a lone pair. A lone pair is simply a pair of electrons that looks like this, not in the form of a bond. Doesn't really matter where you put that lone pair as long as you write it as a pair. In this case, my final 2 electrons go in as one pair, and I have 0 electrons left, which is the point. The last thing you're going to do in step 5 is make double or triple bonds if the central atom has less than 8. So we're going to go back one last time. I know that my hydrogens have octets because I checked that in step 3, but I haven't checked my central atom to make sure that it has 8 valence electrons, so let's count those together now. Maybe I'll switch colors and do this in green. Remember, each single bond is 2 electrons, so the nitrogen has 2 electrons here, 2 electrons here, 2 here, and 2 here. That is a total of 8 valence electrons. Nitrogen has an octet and is also chemically stable. What that really means is that I don't have to do anything for step 5. No double or triple bonds are needed because nitrogen already has 8. It says to draw the final structure here, which really just means adjust these things to be a little bit more symmetrical. Now that I know what is actually surrounding that nitrogen, I can distribute these things a little bit in a slightly more symmetrical way, making this my final Lewis structure for NH3. I guarantee if you follow these 5 steps, you will end up with a really high quality Lewis structure at the end.